Here we go, guys. So we're gonna quickly go over 4B.3, part 4B.4, part 3, relating areas of rectangles to the determinant. Yeah. So here, if my computer cooperates, yeah. So on your part 3, I told y'all that I gave you the notes so that you could watch the video, but there was no video posted. I only posted the completed notes, and I know that for a fact because I did. But the first part was reviewing how to find the area of a unit square under following a linear transformation. Okay. So the key thing here is a unit square. Unit square means that it starts off with the dimensions of 1, 0, or 0, 0. Doesn't really matter how you write it out, but it's made up of ones and zeros, right? Your unit square. Yeah, I think so. Or it was a half sheet. And then from here, when you're manipulating it, we talked about you are if you for whatever reason don't have the note still there, you possibly oh. But it's already cut it. All right, so when we talked about this, we said that because it's a unit square, that means the initial area is 1, right? A unit square is an area of 1, and we're transforming that square. In order to do that, we talked about the determinant. So you're finding the determinant of the matrix. How do we find the determinant of the matrix? Equals, we're going to do what? We cross multiply and then we do what? Subtract. So we're going to cross multiply and then we subtract, right? Okay. So here, again, to find the area of the transformation, the area of the original is, so your OG area is, so your pre-image is 1, right? And then you're going to find the determinant by cross multiplying and subtracting. So 2 times 2 is 4. 4 minus 2 is 2. So my area is 2 square units. Okay, so to find the area after this transformation, again, your pre-image, your OG image is 1 because it's a unit square. Again, we're going to cross multiply. 3 times 4 is 12. 2 times -1 is -2. A negative has a negative makes a positive. So our area becomes 14.
Wait, that's what they do.
Yeah, OG, original. My pre-image. I should be writing the actual word. Pre-image. OG equals your pre-image. Okay. All right. So really quick, please do letter C, making sure that you understand what's taking place. 30 seconds on the clock to do C. The 1 times 4 minus 6, and that leads us to -2. However, area can't be negative, so it's going to be the absolute value of that, which is just 2 square units. Can you find the area of a unit square? Is it terrible? Okay. All right. I'm going to keep going. What happens here? Now it says that you have a rectangle with an area of 7 square units. Are we a unit square anymore? No, we're a rectangle with an area of 7 square units. So that means that our pre-image area is now equal to 7 square units. So our quote unquote OG has changed, right? Now it wants us to find the area of the image underneath this transformation. To find that area, remember it's going to equal the determinant of your transformation times your original times your pre-image. This is supposed to be on like animation. It's not supposed to be there, but it's just there. I don't think my animation's saved. It's okay. Pretend you don't see the answer, okay? So our pre-image was 7. And we're going to find our determinant by cross multiplying and subtracting. A negative times a negative makes a positive. 2 times 1 is. So that gives us 7 times 10, which equals 70 square units. After seeing this, you should be able to do your exit ticket. Does that make sense? On your agenda page, on your modules page, on our course, underneath your grades. It's in like 3 locations. It's in like 3 different locations. You pick which one you want to conquer at this point. All right. Is that terrible? Doable? Doable. All right. Now, what if I'm no longer a square? Uh-oh. Things change a little bit, right? Things get a little weird because now what if you have a triangle and ask what is the area of the triangle? Well, to find the area of a triangle is base times height divided by 2. So we're going to graph our little triangle. It says your triangle is at 1, 0. You have a triangle at 3, 0. And you have a triangle at 3, 2. But the points, the vertices of the triangle are here. So this is my pre-image. How do you find the area of a triangle? Anyway, base times height divided by 2. So in this case, 2 times 2 divided by 2, right? Do y'all remember doing that? So the area of this triangle is 2. Yes? All right, that's easy. When you have the base and the height, bam, wham, bam, thank you, ma'am, we got it, right? Doable, okay? Now, what if it gets a little different? It says determine the image of this triangle. So the image of this triangle is saying that I'm taking this guy right here, and I'm multiplying each one in its own transformation, correct? I have 2 ways of doing this. I can do it by coordinate functions. So I can convert this to being 3x plus y, comma, 3y, right? That's my coordinate function. Do we remember that? Okay. The other option is I can do matrix multiplication. I can do 3, 0, 1, 3 times my ordered pair points 1, 0, 3, 0, and 3, 2. Does it matter which option I do to find the new points? No. Do you remember all of that? Both of those are options on how to find where these points are being transformed. To save time, is going to kind of tell you where they're going by looking right here. So as you can see, after the transformation, do y'all hear my computer? Sounds like it's going to go. Pew. We're still at 3, 0. We're now at 9, 0. So went to 3, 0, 9, 0, and then we went all the way over to 11, 6. So at 11, 6. I wish I could tell y'all what's wrong with my computer, but I don't know what's going on with it. I have no clue. Be kind to the world. You got this.
Question.
Yes.
Second matrix, make it on the third column, the third column, second row, is that a 2 or 3?
It's a 2. It's the 3, 2. Sorry, it got a little weird. All right, so from here, we plot the points. We can see the triangles. And again, does it matter how I get the points? No, because we've learned all the skills. It says, what is the area of the image of this triangle? So to find the area, it's the same thing that we've been doing. It's your original. So this is our OG, our original, our pre-image, times the determinant of the transformation. So the determinant of this transformation equals what? We cross multiply and subtract. What do we get? 9, because we get 9 minus 0, which is just 9. So the area of this image is going to be your original times your determinant. What was our original? What was our determinant? And that gives us 18. Okay, you can geometrically check this by finding the area using base times height divided by 2. So when we look here, this is our base, correct? Our base is 1, 2, 3, 4, 5, 6. This is our height. Your height is what's perpendicular to your base. So your height is actually 1, 2, 3, 4, 5, 6 as well. So your height equals 6. Your base equals 6. What is 6 times 6? 36. What's 36 divided by 2? 18. 36 divided by 2 is 18. So do we see how that matrix determinant and our geometry skills match up, right? Make sense? Yeah, just pretend that they are.
No, but like, you put it at 10-6, no.
That's why I said just pretend that they are. You have the real one right here. I said 11-6, but then when I realized I put it in the wrong spot, we just rolled with it. All right, how is the area of the image triangle in the graph related to the determinant? Well, conclusion is it is the original times the determinant. Ta-da, we did it. Yes. Does it work with all shapes? Yeah. Okay, cool. All right, again, pretend that you don't see the answers. So the linear transformation you have here is applied to the triangle. If the area of the triangle image, so the new one is 70, what was the triangle? What was your pre-image? So you're trying to go backwards, okay? So you know that, and we have to think about this using how we've been finding the area, right? So to find the area, we've been doing the determinant of our transformation times the area of our pre-image, our original. So if we know that the area is 70, can we calculate our determinant? Our determinant is 1 times -6 is 2 times 4 is 8. Can we find our pre? Does that make sense? And that's how it ends up being. So we have 70 equals 40 times our pre. That's not a 14. I don't know what that was. You saw nothing. And we divide. And how do we get 70? Well, 70 divided by 14 is 5. There we go. That's how it ended up being 5. Does that make sense? If I know the pre, or if I know the image area, I can find one or the other. Yes? All right, what if I'm missing a value of my transformation? Could I find from there? Yeah or no? Probably, right? It's going to be a little more complicated, but it is possible, okay? So first thing first is that you know your area of your image is going to be what? 45. So we know that we have 45 equals our determinant times our original. So I have to find what the original is also. Does that make sense? So if I have to draw a sketch, so let's say I'm at 0, 0, I go over to 3, 0. Then I go up to 3, 5. And I go over to 0, 5. What is the area of this rectangle? Three by 5, guys. 15. So the area here is 15. How do I know that? I've used the points that they gave me and I created the rectangle. And the area of a rectangle is length times width. So we know that 45 equals 15 And then now we got to find our determinant. And how do we find our determinant? Cross, multiply, and subtract. So we have 2 times -3, which is -6, minus 4 times k, which is just going to be 4k. So now your job is to solve for k. Is that something you can do? What's the first thing you do? Don't distribute. Divide by 15. Divide everything by 15. And what's 45 divided by 15? 3. So now you're left with 3 equals -6 minus 4k. Is that a problem we all know how to solve at this point? We do. Because they're tight. And that's how we end up with -9/4. Now, the -3/4 comes from if you allow it to be a negative instead of a positive 45. And that's because technically it could have been a -45, right? That's because area is going to always be positive, even if your determinant comes out to be negative, okay? So this is when we have positive 45, and this is when we have -45. And that should be your 4B.4 part, whatever we're on. 3. Doable? All right, so your exit ticket that you should be able to do and get her done fairly quickly, like maybe 90 seconds max, right? On Canvas, it says a triangle with an area of 7 square units is a pre-image of the transformation. What is the area of the image of the triangle? Explain how you determine the area. If you do not explain, you will not get full credit. If you just write a number, I will not give you full credit. Do we hear me? Okay.